All right, so here in this video, we're gonna take a look at translations. All right, so we have the general shape of the graph of an exponential. So it'll look like this if b is greater than 1, and it'll look like this if b is between 0 and 1, right? Again, b always positive. All right, but now like we graphed other functions, so we'll look at it, right? How about some shifts, right? So the first we're going to look at is horizontal here. So f of x, x minus c plus d. All right, so the exponent is x minus c. So here the shifting of c would be c units horizontally. All right, so if it's negative, right, so c would go to the left. Right, and if it's positive, c would go to the right. Right, so for instance, if we have b of x minus 2, that would be 2 units to the right. X plus 2, 2 units to the left. All right, and then d units vertically. Okay. All right, so let's take a look here. Some desmos here. Okay, give me a second here. I didn't have my window set up. Give me a quick second here. Let's do this real quick. Okay. All right, so there we go. So we have our exponential here. All right, so we'll now set. So here we have our general exponential that looks like this. Here, let me zoom out a little bit just so you get a general idea. All right, so here where b is 1 1/4, all right, and d and c are both set to 0, all right, and if we move d, notice here, all right, what it looks like the graph is changing. There's nothing really changing about the graph, all right? We're just kind of the shape at least isn't changing. We're shifting it, and it just because of the window size, it looks like we're actually moving it. But here, as I zoom out further, here you could tell a little better now. Right, so as d fluctuates here, the graph goes up or down, right, depending on what the value of d is, and the same for c. Right, you see it's kind of moving to the left and right depending on what the values of c are. Right? For negative values of c, all right, it moves to the left. For positive values of c, it moves to the right. All right, and as we notice in each one of these cases, all right, our our horizontal asymptote changes with the value of d. All right, so y is going to be d. All right, and here, let's see here. Let me change the line here. Okay, all right, so we see here our horizontal asymptote depending on what d is. All right, that would be my new horizontal asymptote. All right. Okay, and then we see here our, excuse me. All right, so that would be our new horizontal asymptote here. And as far as the, here's 0. Okay, all right, so that corresponds to horizontal and vertical shifts here. Now, in terms of the other type of shift that we're going to take a look at, is a what's called a stretch or a compression, right? So we'll look at here changes in values of A, right? So if we have, so in this case, if the absolute value of A is bigger than 1, then we have a stretch. And if the absolute value of A is between 1 and 0, we have what's called a compression. So it does exactly what those values say is being done, right? So here, let's take a look at our Desmos graph again. All right, so here I have my Desmos graph. Let me put in my A, add a slider for A. All right, and if we look for values of A, right, that are bigger than 1, we see we get a stretch. So here's 1, right? And if we go smaller than 1, okay. All right. All right, so we see here that depending on what those values of A, here, let's make it more. Okay, so here, if I change these values between 0.1, right, notice how it kind of stretches it out, and as I increase the value of A, it looks like it's being compressed, right, kind of squeezed together, right? So that A is kind of just adding to the growth, right? If it is larger than 1, it's growing faster. If it's between 0 and 1, then it looks like it's between 0 and 1, looks like it's kind of stretching out, still growing, but slowing down a little bit by that coefficient of A. All right, and that is a stretch and compression. Notice that here, it just strictly takes into account the absolute value. All right, now, if we did have a negative in front of it, okay, so what that does here, so now we look at reflections across axes, right? If we had f of x equals to negative bx, this is going to correspond to a reflection about the x-axis. And if we move the negative into the exponent, all right, and notice that this becomes 1 over b over x. So if b was a number greater than 1, it now becomes less than 1. This was a number between 0 and 1, it now becomes greater than 1, right? So this will reflect it about the y-axis. It essentially changes if we start off with, if without the negative it will be growth, it turns to decay. If without the negative it would decay, it turns into growth. Right, so let's take a look at what that looks like here. So here, okay. All right, so here, let's just kind of look at, my goodness, negative, and let's turn off these values for C and just keep it at 1, excuse me, at 0, and the D at 0 as well. Okay, so here, B. Okay, so you notice when it's negative, it gets reflected across the x-axis. All right. All right, and if I take the negative off, we'll see, all right, reflects back across the x-axis. Now if I move the negative up into the exponent, all right, so notice here b is greater than 1, so it flipped it from it looking like exponential growth to decay. Now if I mess with our b to be here between 0 and 1, so again notice here that negative in there. Well, if the negative wasn't there, right, it would be decay, right? But the negative there now flips it across the y-axis, right, into a growth type of function. So that's what the effects of these translations are on these. We have a stretch, shifts in the horizontal or vertical directions, and then reflections across a given axis, right? And in general, right, our equation with all the translations here is a b x minus c plus d, where each part plays a role in determining what happens to the graph, right, depending on what these values take on.